Next distribution is Poisson distribution. So after binomial distribution, we have to study about Poisson distribution. Poisson distribution is also a discrete kind of distribution. Okay, discrete kind of random variable is following Poisson distribution, and it is applied for events with rare probability. Rare probability means probability of occurring that event is very rare, it is closer to 0. So this Poisson distribution is applied in the case of n greater than 100. But in most of the problems, if n greater than 25, we can apply this Poisson distribution, and p is approaching to 0. Probability of success is very low, tending to 0. Okay, tending to 0 value. So that if x follows Poisson distribution, and here the parameter is lambda. And what is lambda? Lambda is a number such that it is n into p. N is tending to infinity. N greater than 100 means n is approaching to infinity and p is approaching to 0. So that the product is a constant lambda. So in binomial distribution, we are approximating as n tends to infinity and p tends to 0. So that lambda is equal to np will be a constant, that is lambda. So Poisson distribution is having the parameter lambda, and the distribution function is p of x e raised to minus lambda, lambda raised to x by x factorial, x from 0, 1 to etc. up to infinity. Okay, because n is tending to infinity. So this is the Poisson variable, and we can check whether it is a PDF. For that, sigma over x, f of x or p of x should be 1. So what is sigma over x? Sigma over x e raised to minus lambda, lambda raised to x by x factorial. It is sigma x is equal to x1, x2, etc. xn. E raised to minus lambda, x1, x2, etc. xn is 0 to infinity. E raised to minus lambda, lambda raised to x by x factorial. So it is, this is the variation for x. So e raised to minus lambda is a constant, we can take it out. Then if x is equal to 0, it is lambda raised to 0 is 1 by 0 factorial. If x is 1, lambda by 1 factorial. X is 2, lambda square by 2 factorial plus etc. And what is it? It is the expansion 1 plus lambda by 1 factorial plus lambda square by 2 factorial plus etc. And this is e raised to lambda. E raised to lambda. So e raised to minus lambda into e raised to lambda is 1. Okay. So the total probability is 1. Again, we can find the mean and variance of Poisson distribution with parameter lambda. How will you find the mean? Mean is expectation of x. It is summation x from 0 to infinity x into p of x. It is sigma x from 0 to infinity x into e raised to minus lambda, lambda raised to x by x factorial. Or again we can take e raised to minus lambda outside, 0 to infinity x into lambda raised to x by x factorial is x into x minus 1 factorial. So that x cut ചെയ്യാം. e raised to minus lambda summation 1 to infinity. So it is x minus 1 factorial. So lambda raised to x can be written as lambda raised to x minus 1 into lambda by x minus 1 factorial. So we can take this lambda also outside. So if you give lambda is x is 1, so it is 1 by 0 factorial. If x is 2, lambda by 2 minus 1, 1 factorial. X is 3, 3 minus 1, lambda square by 2 factorial plus etc. Anyway, it is again 1 plus lambda by 1 factorial plus lambda square by 2 factorial etc. So that is the expansion of e raised to lambda. So it is lambda. So mean of the Poisson distribution is lambda. Again variance. Variance is e of x square minus e of x the whole square. So how will you find e of x square? It is e of x into x minus 1. Plus e of x into x minus 1 is x square minus x. So e of x also to be added. So what is e of x into x minus 1? It is summation x into x minus 1 into p of x. Sigma 0 to infinity x into x minus 1 into e raised to minus lambda, lambda raised to x by x factorial. So it is e raised to minus lambda can be taken out 0 to infinity, x into x minus 1, lambda raised to x by x factorial is x into x minus 1 into x minus 2. So that these two terms can be cancelled. So here it is e raised to minus lambda. Now summation x varies from 2 to infinity. The denominator is x minus 2 factorial, so that the numerator also written as x lambda raised to x minus 2 into lambda square. So it is lambda square e raised to minus lambda summation lambda raised to x minus 2 by x minus 2 factorial. X varies from 2 to infinity. Again, if you apply open the bracket, you will be getting 2 to infinity. So C1 plus lambda by 1 factorial plus lambda square by 2 factorial, etc. So again it is e raised to lambda, so it is lambda square. So expectation of x into x minus 1 is, so expectation of x square is e of x into x minus 1 plus e of x. This is lambda square. So e of x is lambda, we have already proved. Therefore variance of x is lambda square plus lambda minus e of x the whole square, that is again lambda square. So it is lambda. So variance of x is lambda, okay, or sigma square is lambda. Variance is represented by sigma square is lambda, or the standard deviation is sigma, it is root of lambda. Okay, so that is the mean and variance of binomial distribution, Poisson distribution. Next, one more thing is there. Binomial, we can write the Poisson distribution, we can derive the Poisson distribution from the binomial. So Poisson is binomial is approaching to Poisson as n tends to infinity and p tends to 0, so that np is equal to lambda. Okay, so what is p? P is lambda by n. Okay, so what is the distribution of binomial? It is ncx p raised to x q raised to n minus x, or it is ncx lambda by n raised to x, q is 1 minus p, so 1 minus lambda by n whole raised to n minus x. Okay, so this means, what is the meaning of ncx n into n minus 1 into etc, n minus 2 into etc, x terms. So n minus of n minus 1 into n minus 2, 2 terms, including this one 3 terms. So up to x means x minus 1 is to be up to n minus of x minus 1 divided by 1 into 2 up to x factorial. Okay, x factorial, then into lambda by n raised to x into 1 minus lambda by n raised to n minus x. Again we can we have to approximate this n to infinity. So for that we have to take this n outside. E bracket and n eduttal, it is 1 into n into 1 minus 1 by n. Here also we can take n outside. So etc. Last term in n eduttal 1 minus x minus 1 by n into divided by x factorial. So that into lambda raised to x by n raised to x into 1 minus lambda by n raised to n minus x is whole raised to n into 1 minus lambda by n whole raised to minus x. Okay, so how many n's are here? N into etc up to n x terms. Okay, this is 1 2 3 up to x minus 1 term, പിന്നെ ഈ ഒരു ടേം കൂടാതെ x terms. So this is n raised to x by n raised to x by x factorial into then lambda raised to x by n raised to x into there is in the numerator 1 minus 1 by n, 1 minus 2 by n etc. up to 1 minus of x minus 1 by n. കഴിഞ്ഞിട്ടില്ല into 1 minus lambda by n the whole raised to n 1 minus lambda by n the whole raised to minus x. Now we have to apply n as n tends to infinity. Approximate n to infinity. Here n raised to x can be cancelled. അപ്പോൾ ഇനി n ഇൻഫിനിറ്റി കൊടുത്താൽ എന്ത് വരും? ഇറ്റ് ഈസ് 1 by x factorial lambda raised to x. As n tends to infinity, 1 by infinity is 0. Okay. So 1 minus 0, 1. Again 1 minus 0, 1. ഈ whole term 1 ആയിട്ട് മാറും. പിന്നെ 1 minus lambda by n the whole raised to n. This one is as n tends to infinity, again 1 now. So limit as n tends to infinity. So it is lambda raised to x by x factorial. Limit n tends to infinity 1 by 1 minus lambda by n the whole raised to n ആവും. ഇതിനെ നമുക്ക് എൽ ഹോസ്പിറ്റൽസ് റൂൾ വെച്ചിട്ട് ചെയ്താൽ 1 minus lambda by n the whole raised to n as n tends to infinity it will be e raised to minus lambda. That is, or we can ഇതൊരു ഫോർമുലയായിട്ട് പഠിക്കാം. x by n the whole raised to n 1 plus x by n the whole raised to n is e raised to x. So here in the place of x it is minus lambda. So it is lambda raised to x by x factorial into e raised to minus lambda. So this is the PDF of Poisson distribution. Okay.